In this video, I'll talk about the halogenation of alpha carbon atom under acidic conditions. Now, you could go ahead and install an halogen at the alpha carbon, which is going to be this one right there, under either acidic conditions or basic conditions. And there is a difference in terms of how the mechanism works and also in terms of how many halogens you can install under acidic versus basic conditions. So it's very important to know what can you do under acidic conditions and what can be done under basic conditions. And a lot of time you would notice that the acidic conditions is a little bit more efficient because you don't want to be installing the halogen multiple times on the alpha position. So I can have pretty much any halogen. For the most part, we would be using either Cl2, Br2, and I2. Those are the most common ones because fluorine is a bad leaving group, so we don't really use that. And the acid would be either an HCl with water, or you can also use acetic acid. Any one of those are fine. So at the end of the day, what I'm really going to get is have this alpha position installed by an halogen. So X here, which could be either chlorine, bromine, or iodine. And then I have an HX as my side product there. Now, how does this really work? So let's talk a little bit about the mechanism. So I can go ahead, use the same guy here, and I want to go ahead and use an Br2 with, let's say, CH3COOH as my acid. So since it's done under acidic condition, it's going to be going through the formation of an enol. So first of all, I want to go ahead and use, so when you writing this acetic acid, you may also see this written as ACOH, which means the same thing. I'll use this acetic acid proton to go ahead and protonate this oxygen first in the first step. That creates a conjugate base. And now I have an hydrogen installed there that gets you the positive charge on that oxygen. And I got the acetate ion there. Okay. And then in the next step, I can go ahead and have an enol formed here, which means I'm going to be going ahead. And so I'm going to go ahead and lose one of these hydrogens here. Um, So this conjugate base comes back. So now it grabs the proton at the alpha position. This falls back to make the enol. And then this pi bond breaks to restore the electron density on that oxygen. So at the end of the day, I'll get, let me just erase this. I got a double bond here. I got an oxygen here with an OH. So now I got the electron density restored there, and I have an acetic acid formed back in there. So now I got the enol formed, and then in the next step, I can have the bromine being attacked by this enol. So I'll go ahead and reform the pi bond here. Then I'll use this pi bond to go ahead and grab onto this bromine, and the other bromine kind of goes away. And that ends up making, I reform the pi bond here to kind of get the ketone back. Now I have one bromine here, and then I have one bromide kind of gone as a leaving group. And then this one bromide that you have in here is going to come back and grab that proton to make the ketone back. And then you have the HBr left as a side product. So you do install only once. That's one of the great things doing this under acidic conditions. You will install this only once. And if you run into a situation where you have multiple alpha positions, you may end up getting a mixture of products. Like for example, suppose I was using this ketone here and doing this with Br2 and acetic acid, suppose, or even HCl. Now I see I have an alpha position on the left side and an alpha position on the right side. So then the question is which position the bromine get installed to? And a typical answer is you may get both of them being installed, but you will have only one of them to be the major. And for right now, whenever you're doing the enol under acidic conditions, you typically want to go with an amore substituted enol as the major intermediate in there. So as a result, this would be your major product, and very likely this would be the minor product. Now, there are ways where you can kind of make this as your primary product, but not necessarily under acidic condition. Because when this is going to be going on to make the enol, I have a possibility of making two types of enol, and then you can ask yourself, hey, which enol is going to be more stable? So I make this enol right there, and I make the enol where the double bond is going to be on the right side of the alpha position. I make this enol. And then since this right side is more, double bond is more substituted, this would be more stable. So as a result, you're more likely to make a product out of this enol here, and you would have this as in a major product in that case. So if you run into a situation where you have two positions where the bromine or the halogen can be installed under acidic conditions, you're more likely to go to the side that would be making in a more stable enol, or you can say in a more substituted side. But a lot of time you may not have to worry about it because, even though you make this as in a major product, you still have a little bit of this made, and making in a mixture of product is always kind of a bad thing when you're actually doing the synthesis in the lab. But if it's only one alpha position like we got in there, it's in a win-win situation where you don't have to worry about um, making another product, and you also don't have to worry about over installing the halogen. It gets installed only once under acidic condition.